Hi everyone, it's Math with AUB. After the completion of sine and cosine, how to deal when their powers are even or collectively they have even powers or odd powers, we have handled them. Now let's see what about the rest. Tan, cot, sec, cosec, individually or in mix up, whether power is even or odd, they are handled in the same fashion. Just keep in mind what is the derivative of tangent, what is the derivative of sec, what is the derivative of cot and what is the derivative of cosec. Let's see and find out. Today our question number 1 is 10 raised 4x. We have to integrate 10 raised 4x dx. Now we have to transform this situation into function derivative or to a function whose differentiation is known to us. I can write 10 4 as 10 square x times 10 square x. Okay, cool. If I replace 10 square by sec square minus 1 according to trigonometry, 10 square x same sec square x minus 1 dx. Now look at this, our question is taking shape. Function derivative situation is propping up, is on the advent of the horizon. 10 square x times sec square x dx minus 10 square x dx. Look at this, it's our function, it's our differentiation. Function derivative, add 1 into the power of function, it will become 10 cube divided with the same. What about this? 10 square, it is not differentiation of anything. Again, utilize the same formula. Instead of 10 square, we can write sec square x minus 1 dx. Now ask yourself, sec square is differentiation of 10. Sec square is differentiation of 10 and 1 is differentiation of x because our variable is x. Sec square x dx plus 1 dx. Now integration of sec square is 10. Integration of 1 with respect to x is x. 1 over 3, that is 10 cube. 1 over 3 10 cube x minus integration of sec square is 10. Directly 10 derivative of differentiation of 10 is sec square. So integration of sec square is only 10. And 1 is differentiation of x, so integration of 1 is x plus c. That's our answer in that case. Look at this. Tiny properties are utilized. Function derivative situation must be there. If not something direct, they must be there. We have to transform this quantity into function or sum or difference of functions whose differentiation or integration is directly known, or function derivative situation props up. Okay, cool. Now let's see tangent 5. It's really very cool. It's really very easy. Tan 5. 10 raised 5x dx. Okay, I can write tan 5 as 10 cube x times 10 square x dx. Again, 10 square is equal to sec square minus 1. From trigonometry, we have 10 cube x. 10 square is equal to sec square x minus 1 dx. Multiply throughout 10 cube x sec square x dx. 1 with 1 it will become 10 cube x dx. Look at this, function derivative. Add 1 to the power of function, it will become 10 4. Divide with the same. Here, same mystery or trickery, it can be written as 10 into 10 square. Instead of 10 square, utilize same formula and you are going to get through. 10x times 10 square x minus 1. Again, 10 square is equal to sec square minus 1. It can be written as same 1 over 4 10 raised 4x dx. Now integration 10x times 10 square means sec square x minus 1 dx. Multiply 10 throughout, 1 over 4 10 raised 4 minus 10 times sec square x minus plus, that's our 10x dx. Okay, cool. It is same, already integrated. 10 4x. Function derivative, add 1 into the power of the function, divided the same. Look at this. Now we have here 10. 10's integration is directly known to us. 10 is ln sec plus c. Integration of 10 is ln sec plus c. Integration of 10 is ln sec plus c. It's answer in that case. Okay, cool. Let's see collective powers of cot and cosec. Cot and cosec. We have cot raised 5x time cosec cube x dx. A really good question. Both are odd. Cot raised 5x time cosec cube x dx. Okay, cool. Now, if I write cosec cube as cosec square x into cosec x dx, if I convert cosec into 1 plus cot square time cosec, this is also cot. Differentiation of cot is cosec square. Differentiation of cot is cosec square. And I am not in a position to transform complete cosec square, cosec cube into 10 cot 5. Similarly, I cannot transform cot 5 directly to cosec in something. So what about this? If I take cot from here, cosec from here, and differentiation of cosec is cosec and cot, work in that fashion. When both have powers odd, work in that fashion. Even this tip is valid for 10 having power odd, sec having power odd. So cot 5 can be written as cot 4x, cosec cube can be written as cos square x. Cot 5, cot 1 there, cosec 1 there. Okay, cool. Look at this. This is our game changer. Cot and cosec. Differentiation of cosec is minus cosec and cot. Only deficiency of minus we can manage. We have to convert this complete function into cosec, not cot, into cosec. Cot square, cot 4 can be written as cot square times x times cot square x. This is cosec square x, same. Don't break this symmetry. Keep this intact. Cot x cosec x dx. Instead of this, this is cosec square minus 1, this is also cosec square minus 1, and we are going to get through. Cosec square x minus 1, this is also our cosec square x minus 1, this is cosec square same, times, don't multiply this quantity, keep it intact, it's our beauty, it's our game changer. This is differentiation of cosec with tiny deficiency of minus, multiply them throughout identity, a minus b whole square, it will become square of cosec square is cosec 4 minus 2 times cosec square x plus 1. We have managed the multiplication of these two. Cosec square is there as well. Don't forget to write cot x time cosec x dx. Okay, cool. Now multiply these quantities throughout. It will become cosec 6 x cosec square into cosec 4 cosec 6 and this one. That is our cot x and this is our cos x dx. Look, I am not multiplying cosec 6 and 1 7. No, it's our function, it's our derivative. I have to keep cot and cosec intact. Minus 2 cosec square it will become cosec 4. Let me write cosec clear. Cosec 4x times this quantity same cot x cosec x dx. Okay, cool. What about this? Multiply this with 1. It is cosec square x times cot x cosec x dx. Now look at this, it's our function, it's our derivative with tiny deficiency of negative, function, derivative, tiny deficiency of negative, function, derivative with tiny deficiency of minus. I can manage. It will become cosec 7x divided by 7. Here is your deficiency. I have compensated the deficiency. Here function derivative minus 2 cosec 4 will become cosec 5. Divide with the same. Here is your deficiency. It will become minus minus plus. Similarly, cosec cube means add 1 to the power cosec cube divided by 3. That's our minus. It will become negative negative positive, positive negative negative, and it's our answer in that case. So our final answer is 1 over 7. Let me write cosec in abbreviation, cosec 7x minus minus plus 2 over 5 cosec raised 5x 7 5, and the final one is third one x minus 1 over 3 cosec cube x plus c, cosec cube x plus c. It is the integration of this one for you, cot 5 into cosec cube. Both powers are odd. I have managed cot 1 and cosec 1. From this I have decided my cosec is going to be our function cosec, because differentiation of cosec is cosec as well as cot. with deficiency of minus, we have managed in the end. Function derivative situation works wonderful for us. Okay, cool. What about 10 cube and sec cube x? Same pattern like this. Let me read this first. Okay. 10 cube x times sec cube x dx. Both powers are managed. 10 from here, sec from here, and 10 sec is the integral. There's differentiation of sec, and it's wonderful for us. 10 square x sec square x times 10x and sec x. This is our game changer. This is differentiation of sec. So we have to convert this 10 square into sec. It is to be sec square x minus 1 times sec square x 10x sec x dx. Okay, cool. Multiply this throughout and this one. It will become sec 4x times 10x sec x. Look, I am not multiplying sec 4 into sec. I am not writing this sec 5. No, I know that this is my function, this is my derivative. I need this as it is. Dx minus this one with this one. 1 times sec square x times 10x sec x dx. Okay, cool. Function derivative, add 1 to the power. Sec 5x, no deficiency. Good. Sec square means 2 plus 1, 3. And it's our tiny answer in that case. It is our tiny answer in that case. Okay, cool. We have handled 10 having power even odd, mixed power of quat, mixed power of 10 and sec, and finally even power of cosec. Similarly, you can handle sec raised 6. Let's see and find out how to integrate this one as well. Cosec 6. Maybe I have selected the long one. Cosec cosec 6x dx. Okay, I need at least cosec 6 can be written as cosec square x times cosec square x times cosec square x times dx. Look at this. Cosec square is the differentiation of cot with deficiency of minus. I have to convert both of these into cot. It is to be 1 plus cot square. It's also 1 plus cot square x and our cosec square dx. Look at this one. Cot is our function, cosec square is our differentiation. With tiny deficiency of minus, we can manage. Multiply them, whole square formula. 1 square plus 2 times cot square x. Square of cot square is cot 4x times cosec square x dx. Multiply throughout, I have cosec square x dx plus 2 cot square x times cosec square x dx plus cot raised 4x times cosec square x dx. Okay, cool. Integration of cosec square is minus cot. Final step. Function derivative with deficiency of minus. Add 1 in the power of the function, divide with the same. Here is the deficiency. We have compensated. Function derivative, it will become cot 5x dividing with 5, a deficiency of minus positive. See, plus minus minus plus minus minus. Let's see and find out. It is our minus cot x minus 2 over 3 cot cube x minus 1 over 5 cot raised 5x plus c and so on. It's so on. That's our integration of cosec 6. Cosec 6, I have split cosec square times cosec square times cosec square. One cosec square is enough. It is a differentiation of cot square. I have converted both of these cosec square into cot square. Just simply work wonders. There is cosec square means direct minus cot. Function derivative added 1 to the power, that is cot cube. There is cot 4, cot 5 plus. It's my tiny effort for you to explain to you trigonometric integration. I have integration of sine, cosine and their formulas, how to prove them. They are available on my YTC. It's all by itself. Next.